July of 1994, something the size of a mountain hit Jupiter. Not once, 21 times. The largest impact released the energy of 6 million nuclear warheads. And Jupiter didn't even flinch. You've been told Jupiter is our protector, the solar system's shield. That is not the whole truth. What Jupiter actually is something far stranger and far more dangerous than anyone told you. Start with size, not the polished version, the real version. Jupiter contains more mass than every other planet, moon, and asteroid in this solar system, combined. Then doubled. Then add 50% more. It is not a big planet in a solar system of planets. It is a near-stellar object that tolerates the rest of us. If you flew a commercial airliner around Jupiter's equator, the flight would take more than 7 months without a single stop. But size is the least terrifying thing about it. Jupiter generates the most powerful magnetic field of any planet in the solar system, roughly 20,000 times stronger than Earth's. This creates a magnetosphere so vast it extends 2 million miles toward the Sun and stretches a tail of charged particles past the orbit of Saturn. If you could see it from Earth, it would appear 5 times wider than the full moon in our sky. Inside that field, orbiting directly within it, is Io. Io is the most volcanically active body in the solar system, with over 400 erupting volcanoes. And the radiation environment around Io, generated by Jupiter, is lethal to a human being in under 10 minutes. Not uncomfortable, not dangerous, lethal. Now go deeper. If you tried to land on Jupiter, you wouldn't find a surface, you would fall. The atmosphere thickens from gas to something like a liquid to something with no name in human experience. About 10,000 miles down, the pressure compresses hydrogen so completely it stops being a gas and becomes a metal. A liquid metal that conducts electricity. This metallic hydrogen is what generates that catastrophic magnetic field, and it behaves by rules we have never observed in a laboratory at that scale. Deeper still, there is a core, we think. The Juno spacecraft has been orbiting Jupiter since 2016, and its gravity data suggests the core is not a solid sphere, but something diffuse, fuzzy, partially dissolved under pressures reaching 70 million times what you feel standing on Earth's surface. The temperature at that depth exceeds 43,000 degrees Fahrenheit, hotter than the surface of the Sun. Here is the fact that should follow you. Jupiter is not a star, but it almost was. If Jupiter had accumulated roughly 80 times more mass during the formation of this solar system, the pressure at its core would have ignited nuclear fusion. It would have become a star. We would not be here. Earth, at this distance, would have been scorched. What we call life would have had no opening to exist. Jupiter already radiates more energy than it receives from the Sun, a residual heat from its own gravitational compression, slowly cooling across billions of years. It is a failed star. Cooling, still enormous, still violent. And the margin between failed star and star that ends Earth was a matter of accretion, of which dust clouds happened to cluster nearby 4.5 billion years ago. Now the shield myth. The story goes, Jupiter's gravity intercepts comets from the outer solar system, pulls them in, and Earth is spared. Shoemaker-Levy 9, the comet that struck 21 times in 1994, is always used as the example. Jupiter caught it, so we didn't have to. But planetary scientists Jonathan Horner and Barry Jones ran the simulations. The results were uncomfortable. Jupiter does deflect some long-period comets, but its gravity also acts as a slingshot, accelerating others directly into the inner solar system. On net, their models suggest Jupiter may actually increase Earth's impact risk from certain classes of comets. The shield is also a catapult, and we live downrange. Beneath the ice of Europa, one of Jupiter's 95 known moons, there is an ocean, liquid water. Estimated to contain more water than every ocean on Earth combined. Heated not by a sun, but by the gravitational flexing Jupiter exerts on Europa's crust. creating friction, creating heat. It is possible, by every measure of astrobiology we have, that something lives in that ocean right now. We have never looked. NASA's Europa Clipper mission, launched in 2024, will reach Jupiter in 2030. Whatever it finds will be one of the most significant moments in human history. Or it will confirm that even in liquid water, next to a world of unimaginable violence, nothing is home. Jupiter does not protect us. Jupiter does not threaten us. Jupiter does not notice us. It has been there for 4.5 billion years, a near star, a radiation engine, a world with no floor, generating storms that outlast civilizations, pulling moons into tidal violence, deflecting and launching debris with equal indifference. And in all that time, on a pale, fragile rock about 5 times smaller than the Great Red Spot alone, chemistry found a way to become biology, and biology found a way to build telescopes and point them at a storm that has raged longer than our species has existed. That is not comfort. That is context. The universe did not make room for us. We exist in the margins of a system built around something that almost became a star and didn't. The margin is everything we have ever known. If this changed the way you see our solar system, consider subscribing. New episodes go up every week, and next time, we go somewhere even less forgiving. I'll see you then.